In this video, we're going to take a look at a review of graphing an exponential function, or a function where we have our variable in the exponent. And then we're going to also take a look at graphing its inverse. So let's take a look at our example. The function is f of x equals 3 to the x power. And I've chosen -1 through 3 as my x values. And I'm going to substitute every x value in and get an output. So 3 to the 0 is 1, 3 to the -1 is 1/3, and for each of these points I'm plotting them on the coordinate plane. So 3 raised to the first power is 3, then 9 and 27, which we know will be off our graph. So I'm going to connect each of these points. If I've done my job correctly, it should be a curve, and we know that it should get really close to the x-axis, but it shouldn't actually touch or intersect the x-axis. And now what we want to do is really focus on its inverse. So in order to do that, instead of taking a look at f of x equals 3x, let's rewrite that as y equals 3 to the x. And when we want to do an inverse, remember from our studies of inverse functions, that means that we're going to flip our x and our y variables. So now x equals 3 raised to the y variable. So that's what I'm going to graph. And instead of asking you what is the graph of x equals 3 to the y, most likely you'll be asked with, come up with the graph of the log base 3 of x. And so we know that from our last video that we can convert log base 3 of x equaling y to x equals 3 raised to the y power. And that's really how we want to think about coming up with our table, because it'll be easier for us to compute and raise 3 to a power than it will be for us to think about what the log base 3 of a value is. So I'm going to pick y values. That's going to be the easiest way to go about this, because every y value that I pick, I can just raise 3 to that value, and I get out the x coordinates 1/3, 1, 3, 9, and 27. And again, from our studies about inverses, we see that our green table and our red table have the exact same values, but the x's and the y coordinates are just flip-flop. Okay, so I know I'm on the right track. I'm going to graph and plot each of these points. I should still get a curve, but this time my graph should be reflected over the imaginary line y equals x. So now I should have a curve, but this time it will go through the x-axis, but it won't ever actually cross the y-axis. It'll get really close, but it'll never cross. So let's take a look at a couple properties of each of these. If we look at what the domain is of our initial function, our exponential function, recall that our domain of any exponential function here that we've taken a look at in general is -infinity to infinity. You can plug in any x value. But if I take a look at my log function, my domain now is only from 0 to infinity. It only covers or allows me to input positive values. If I still stick with that log function and I take a look at the range though, this time I cover both negatives and positives, so -infinity to infinity. Comparatively, for my exponential or my green function, the range we know that to be 0 to infinity. So if we notice a pattern here, the domain of my initial exponential function is exactly the same as the range of my log function. And the range of my exponential function is exactly the same as the domain of my log function. That will always be true, and it's true because the log function and the exponential function are inverses, and so we switch our x and y values. Couple extra just things to point out. We know our y-intercept for our first function is 0, 1. Now our x-intercept for the red function is y0. We know that we never have an x-intercept for our initial function, and now for our log function, we won't have a y-intercept. So in general, what we want to take away from this lesson is to graph any log function. I'm going to first want to convert that or rewrite that function as an exponential function, just because it's so much easier for me to calculate values. And I want to pick y values in my table to make it easier on myself and then calculate out the x values accordingly.